So in this first video in Lesson 7, what I want to do is introduce you to the idea of the domain and the range of what are called continuous functions. I want to remind you of an example we did in Lesson 6 where we identified a relation where there was a person who goes to work, and when they worked 17 hours in a week, they earned $170. When they worked 19 hours in the week, they earned $190. And when they worked 24 hours in the week, they earned $240. And we said that this is a function because none of the numbers is repeated with a different output variable. Okay, that each input variable has a unique output variable. But this is what's called a discrete function. A discrete function means that there are a limited number of inputs. Right here, there's only 3 inputs, and there are a limited number of outputs. In this case, only 3 outputs. And so, what's different about what we're going to do today in Lesson 7 is we're not going to be dealing in a limited number of inputs and a limited number, well, it might be a limited number of outputs, but it won't be a limited number of inputs. We're going to have what are called continuous functions, which means that there is an infinite number of inputs. What do you mean by continuous function, Mr. Ryan? Well, imagine that you're in a classroom, and let's say the teacher is in the classroom and there are also 25 students in the classroom. If we ask the question, how many people are in the classroom, the answer would be 26. If somebody leaves the classroom, then there would be 25. But the answer to how many people are in the room is always an integer. It's always a whole number, okay? We can't say that there are 25.4 people in the classroom because there's no such thing as 0.4 people. When we count human beings, we don't count bodies, we count souls. So even if a person came in and they had no arms and no legs and they were in a wheelchair, that would still count as one person. We wouldn't give them a decimal value because we're not counting how much of their body is in the room, we're counting them as a whole person in the room. And so people are counted discretely. We cannot have 1.5 people in the room. We can have one person in the room, or we can have 2 people in the room, or we can have 3 people in the room. It has to be a whole number. That's called a discrete variable, okay? But now, if we were to think about how far a person is from their house when they walk out of their house. Let's say they walk down the street and around the corner to a friend's house. Let's say we were measuring how far they were from their house in feet, okay? So they could be 30 feet from their house. But if they take a little tiny step like this, if they take half of a foot step, they could be 30.5 feet from their house. They can even be 30.5792 feet from their house because distance in feet has a decimal value to it. It's incremental. And since distances are incremental, they're not just in feet, we call that a continuous variable. And if we were to ask continuously how many numbers are between 30 and 31 continuously, the answer is an infinite number of values. Because we can have 30.000001, 30.000002, 30.00000, and the decimals can go out infinitely. And so that's what we call a continuous variable. And so let's think about this person working 17 hours or 19 hours or 24 hours. Isn't it possible when they went to work, isn't it possible that instead of working 17 hours or 19 hours, isn't it possible that maybe they worked 18 hours or 18.5 hours or 18.57 hours in a week. And it's possible that they worked 0 hours. Let's say they were out of town on vacation, so they worked 0 hours. When I used to work at Walmart, they had a rule that said that nobody was allowed to work more than 37 and a half hours. That's 37.5 hours in a week. And so, but we could work 0. If we were on vacation, we would work 0 hours. And so what we do with continuous variables, instead of creating a set of the input and a set of the output, continuous variables, oops, I forgot a U in there. Continuous variables have a domain or range, have domain and range as intervals. And you're familiar with intervals. Remember, intervals are the answers we get when we do inequalities. Greater than, or equal to this number, or less than that number, or something like that. And the thing is, at Walmart, any employee could work as few as 0 hours and as many as 37.5 hours. And if we write this as an interval with the brackets, this represents the domain of the hours worked for an employee at Walmart. And any number that is on this interval is a part of the domain. Like 5 is on this interval. 5.7 is on this interval. 5.79286 is on this interval. Okay? And so that's what we're going to do today in lesson 7, is we're going to identify the domain and range of continuous functions rather than discrete functions. So the way that we're going to begin to understand how to identify the domain and the range of continuous functions is I want you to create this chart in your notes, okay? And what we're going to do is there are 7 kinds of functions, 7 kinds of continuous functions that we are going to examine. There are 7 kinds of continuous functions that are actually going to be in your homework and in your quizzes, okay? And what we'll do is we'll look at each one of these one at a time, and I will show you how to identify the domain of each one of these and how to identify the range of each one of these except one. We're not going to actually do the range of a rational function. That's its own topic in itself. So go ahead and pause the video and copy this chart into your notes, and then what we'll do is in the next few videos we will go through these one at a time, or a couple at a time maybe, and figure out how to identify the domain and the range. The last thing I want to say in this introduction is I want to show you how we write continuous domains and continuous ranges in interval notation. You've seen these before already when we did inequalities. And what I want to show you is this. Do you see this interval here? This interval includes all numbers between negative infinity and positive infinity. When we say that an interval is from negative infinity to positive infinity, we're basically saying all numbers. Every single real number is included in this particular interval. And there are several situations of these functions, these continuous functions, where the domain is all the numbers, that there are no restrictions. You can plug any number in. And that's what we're looking for here. We're looking to see if there are any numbers that can't be inputs, or if there are any numbers that can't be outputs. And if numbers can't be inputs, or if they can't be outputs, then we're going to leave them out of the domain and range. And here are 3 examples of how you leave numbers out. This says all the numbers from negative infinity up to 5, and then also all the numbers from 5 up to infinity. But there's one number that's left out of this, and that's 5. You may say, but I see 5 right there. Yeah, but look, it has the parenthesis. And remember, when we do an open interval, that's called an open interval. When we do an open interval, we're not including the number that's listed there. So this is what we write when we want to leave 5 out of the domain or range. When we want to leave 5 out of the interval, we write it like this. This interval right here says start at 4 and go up to infinity. And so in this interval, we're leaving out all of the numbers less than 4. Note there's a bracket. That means we're going to include 4. We could also write an interval that doesn't include 4 but starts at 4. If we do parenthesis 4 up to infinity, then this would start at 4, go up to infinity, but it would not include 4. This one includes 4. This one does not include 4. But both of these intervals leave out every number smaller than 4. This interval right here includes all numbers from negative infinity up to 7, but it leaves out all numbers larger than 7, okay? And so when we leave numbers out of a domain, we say that the domain is limited or the domain is restricted. When we leave numbers out of the range, it's the same thing. We say that the range is limited or restricted.